For millennia, humans relied on fire for light. From the earliest days, fire was a source of warmth, protection, and a means to extend the day beyond sunset. Ancient civilizations used torches and oil lamps, creating rudimentary yet effective ways to illuminate their surroundings. These early light sources were central to community gatherings, rituals, and daily life. Fire was a fickle friend, dangerous and difficult to control. It required constant attention and a steady supply of fuel. The risk of uncontrolled fires was ever present, leading to devastating consequences. Despite its dangers, fire remained the primary source of light for thousands of years. Everything changed with the invention of the electric light bulb. This groundbreaking innovation marked the beginning of a new era. No longer were people bound by the limitations and hazards of fire. The electric light bulb provided a safer, more reliable source of illumination. Thomas Edison's incandescent bulb, a filament heated to white-hot temperatures, revolutionized the world. Edison's work made it possible for homes and businesses to have consistent, bright light at the flip of a switch. This invention not only changed how people lived, but also how they worked and interacted with their environment. Suddenly, night became day, and homes and streets were bathed in the warm glow of electric light. The transformation was profound, affecting every aspect of society. Public spaces became safer, productivity increased, and the quality of life improved significantly. The electric light bulb became a symbol of progress and modernity. Incandescent bulbs, however, were not without their flaws. They had a relatively short lifespan and were prone to breaking. The delicate filaments inside the bulbs were easily damaged, leading to frequent replacements. They were inefficient, wasting much energy as heat, and fragile, their delicate filaments prone to breaking. This inefficiency led to high energy consumption and increased costs. The search for a more durable and energy-efficient light source became a priority for scientists and inventors. The search for a better light source continued, leading scientists down new and exciting paths of discovery. Innovations such as fluorescent lights and, more recently, LED technology have transformed the way we light our world. These advancements have provided more efficient, longer-lasting, and environmentally friendly lighting solutions, continuing the legacy of progress started by the humble incandescent bulb. The story of the LED begins in the early 20th century, not in a prestigious laboratory, but in the workshop of a Russian radio researcher named Oleg Losev. Losev was a curious and dedicated scientist, always tinkering with radio equipment and exploring the unknown realms of electronics. His workshop was filled with an array of vintage radio components, diodes, and other early semiconductor devices, a testament to his relentless pursuit of knowledge. In 1927, while experimenting with diodes, Losev noticed something peculiar, a faint glow emanating from the junction of two different semiconductors. This unexpected phenomenon caught his attention, and he meticulously documented his observations. He realized that this glow was not due to heat or any other known cause at the time, but rather a new and intriguing effect. He had stumbled upon electroluminescence, the principle that would later form the basis of LED technology. Electroluminescence is the process by which a material emits light in response to an electric current or a strong electric field. This discovery was groundbreaking, as it opened up new possibilities for light sources that were more efficient and durable than traditional incandescent bulbs. Losev's discovery, however, was ahead of its time. Despite his detailed research and published papers, the scientific community of the 1920s and 1930s did not fully grasp the significance of his findings. The world was still heavily reliant on incandescent and later fluorescent lighting, and the potential of electroluminescence remained largely unexplored. The world was not yet ready for LEDs. The technology and materials needed to fully harness electroluminescence were not yet developed, and it would take several more decades of research and innovation before Losev's discovery could be transformed into practical applications. It wasn't until the 1960s that researchers at General Electric, building on Losev's work, developed the first practical visible spectrum LED. These researchers, equipped with more advanced materials and a deeper understanding of semiconductor physics, were able to create LEDs that emitted visible light, marking a significant milestone in the history of lighting technology. This breakthrough paved the way for the LED revolution. Today, LEDs are ubiquitous, found in everything from household lighting and electronic displays to automotive headlights and medical devices. The journey from Losev's humble workshop to the modern LED revolution is a testament to the power of curiosity, perseverance, and the relentless pursuit of scientific discovery. LEDs are not magic, though their ability to produce light from semiconductors might seem like it. These tiny lights have revolutionized the way we illuminate our world, from the screens of our smartphones to the headlights of our cars. But how exactly do they work? The secret lies in the movement of electrons within the semiconductor material. Semiconductors are materials that have properties between those of conductors and insulators. They can conduct electricity under certain conditions, making them perfect for controlling electrical currents. When an electrical current is passed through a diode, a special type of semiconductor, electrons move from a higher energy level to a lower one. This movement is crucial because it is during this transition that energy is released. This transition releases energy in the form of photons, tiny packets of light. The process is known as electroluminescence. The efficiency of this process is what makes LEDs so bright and energy efficient compared to traditional light sources. The color of light emitted depends on the type of semiconductor material used and the energy difference between the two energy levels. Different materials have different band gaps which determine the color of the light. For example, gallium arsenide emits red light, while indium gallium nitride emits blue light. By carefully selecting materials and manipulating their properties, scientists can create LEDs that emit light across the entire visible spectrum, from red to violet and beyond. This versatility has opened up countless applications, from energy-efficient home lighting to advanced medical devices. The future of lighting is bright, thanks to these tiny yet powerful lights. Early LEDs were dim and limited in color, primarily used as indicator lights in electronics. Over the decades, however, LED technology has advanced at an astonishing pace. Scientists have developed new materials, improved efficiency, and increased brightness, transforming LEDs from simple indicators to powerful light sources. One of the key breakthroughs was the invention of the blue LED in the early 1990s. This missing piece of the LED puzzle allowed for the creation of white light by combining red, green, and blue LEDs. White LEDs revolutionized lighting, offering a long-lasting, energy-efficient alternative to traditional incandescent bulbs. Section 5. LED Facts and Figures, Illuminating the Numbers. The numbers speak for themselves. LEDs are incredibly efficient, converting up to 80% of electrical energy into light, compared to just 20% for incandescent bulbs. This efficiency translates into significant energy savings, both for consumers and the planet. LEDs are also incredibly long-lasting, with lifespans of up to 50,000 hours or more. This means an LED bulb can last for decades under normal use, far surpassing the lifespan of incandescent bulbs, which typically last only a few hundred hours. The environmental benefits of LEDs are undeniable. Their energy efficiency reduces our reliance on fossil fuels, lowering greenhouse gas emissions and combating climate change. Their long lifespan reduces waste, as fewer bulbs end up in landfills. LEDs are also free of harmful substances like mercury, which is found in fluorescent bulbs, making them a safer and more environmentally friendly lighting option. From reducing energy consumption to minimizing waste, LEDs are illuminating a path towards a more sustainable future. Today, LEDs are ubiquitous, found in everything from our smartphones and television screens to traffic lights and street lamps. They light our homes, offices, and cities, providing brilliant, energy-efficient illumination. LEDs have also revolutionized other industries. In agriculture, LED grow lights are used to enhance plant growth and increase yields. In healthcare, LEDs are used in medical imaging and therapy, improving diagnoses and treatments. The future of LED technology is bright, with endless possibilities for innovation and advancement. Researchers are exploring new materials and designs to create even more efficient, brighter, and versatile LEDs. Imagine a world where LEDs can be integrated into fabrics, creating interactive clothing displays, or illuminating our paths at night. Imagine LEDs used in biomedicine, delivering targeted treatments within the human body. The potential of LED technology is limited only by our imagination. From humble beginnings as dim indicator lights, LEDs have evolved into powerful and versatile light sources, transforming our world in countless ways. Their energy efficiency, long lifespan, and environmental friendliness make them the clear choice for a sustainable future. As LED technology continues to advance, we can expect even more innovative applications and a world illuminated by the brilliant glow of these tiny but mighty lights.